So it's only a matter of time before electric vehicles are the predominant form of transportation. There's still many challenges that remain. Everybody here should be familiar with them, right? You've got range anxiety, charging time, power, performance, especially in extreme temperatures, battery degradation, exorbitant costs, and also a heavy reliance on rare earth minerals like lithium and cobalt. Now, we made a lot of progress recently. In fact, we've heard about that progress today, which is great. But what if I told you that there was a material, just a single material, that could revolutionize every single one of the areas that I just spoke? And what if I told you that this material is often referred to as the single most valuable material ever discovered? And yet, outside the science world, most people have never even. I'm going to take you back in time a little bit. 20 years, 2004. Two scientists in England were performing a groundbreaking experiment using a very complicated tool, which was a strip of Scotch tape. They took this tape and they put it on the side of a chunk of the mineral graphene. When they peeled it back, they revealed an ultra-thin layer of carbon atoms. These atoms were perfectly bonded together in a hexagonal honeycomb-type pattern. Like, oh, this is interesting. They test the material, and the properties that they find were entirely new and incredibly exciting. In fact, in 2010, for their discovery, they were awarded the Nobel Prize. This material is called graphene. Now, graphene reads like something out of a sci-fi. It's truly remarkable. It is 200 times stronger than steel, but it's lighter than a feather. In fact, it's the strongest and the lightest material ever discovered. It's the thinnest material ever discovered. It's thinner than human hair. To scale, if you took a piece of paper and held it up against a skyscraper, the skyscraper is the human hair. The paper is the layer of graphene. It's literally one atom thick. It's impermeable. Even helium and hydrogen atoms cannot pass through it. It has the highest surface area of any material ever discovered. In fact, 1 gram of graphene powder could cover more than an entire football field. It has the highest thermal conductivity of any material ever discovered, far more so than even diamonds. And it has the electrical conductivity of, yes, you guessed it, the best ever discovered. Its electron mobility is 100 times faster than silicon, which is, as you know, better. But also, it has chemical reactivity, where you can tailor properties on the surface to apply it to different applications, which opens up a world of possibility in things like energy and energy storage, supercapacitors, superconductors, battery efficiency, and advanced materials. So just think about how something this powerful could impact the EV battery space. Do you remember some of those challenges that I talked about earlier, right? Like range anxiety. By integrating graphene into an existing battery, you are almost instantly increasing its ability to conduct energy, which has a direct impact on its energy density. And what you see then is how far you can drive that car goes way up on a single charge. A charge which, by the way, might only take a couple of minutes, and those charging cycles don't lead to additional battery degradation because graphene has an incredible ability to thermally regulate, and also it has structural stability. So now you have a longer lasting, more durable, more reliable power supply for that. Also, those thermal management properties is going to make it so in extreme temperatures, whether it's heat or whether it's extreme cold, you're going to see consistent performance. And also, graphene eventually we can see a lessening or perhaps an elimination of our reliance on these rare earth metals. So we have a more sustainable, but also a less dependent supply chain, which is very, very important. So this is all awesome. It's great. It's fantastic. But you're probably all asking yourself a very logical question. What's the problem? Where is all the graphene? Well, we asked ourselves that exact same question. 10 years ago, excitement was so high for this material and it just changed. Why? And the answer is very simple. Since its discovery, no one has yet figured out how to produce an affordable, high-grade, commercial scale supply of graphene. That's not to say that they're not trying. Trust me, they are. There are some very large, very impressive companies today in the graphene space. The issue is their method. There's two primary ways of producing graphene today. I'm dramatically oversimplifying this. But the first way is to grow it from scratch in a laboratory. It's not too dissimilar from those crystal growing kits we all had as kids, just much more. The second way is to take a chunk of graphite rock, soak it in harmful chemicals, and then layer by layer exfoliate the graphene up. For various reasons, both of those are environmentally toxic. They produce a very small yield. They're incredibly expensive to not only produce, but expensive to scale, which leads to an increased cost for the consumer. And for the most part, the properties from those methods are subpar. So if you're an EV battery company and you would love to get your hands on this material, you can't. Because there is no economical supply. That is where we come in. I haven't introduced myself yet, but my name is Ben Tyson. I'm from Colorado. I'm very excited to be here in Florida, so thank you for the invitation. Finally, we're learning how to breathe in this air. Almost. But I'm the CTO and co-founder of a company called Heisenberg Graphene. And our mission is to become the first commodity scale supplier of graphene worldwide. So how do we do this? Well, we have developed a patented method to produce graphene from plant-based fibers. Specifically, the fibers inside the stalk of industrial hemp. So hemp is already one of the strongest plants on Earth, and it's exceedingly rich in carbon, which happens to be the key and the only ingredient in graphene. So, traditionally, graphene comes as a single machine. Sometimes it's stacked layer upon layer upon layer, holding the nanotubes. Ours is a little different. Because of the nature of plant fibers, our graphene is three-dimensional. It's a little thicker, sure, but that's okay, because it has actually increased structural flexibility. It has an increased surface area naturally, and also those intersection points don't add any resistance to the flow of electrons. So that means that our material, when it's in the areas of energy and energy storage, in contrast to existing graphene, perform at or above the benchmark set by the Nobel Prize material. How do we manufacture this? Well, really good science, for one, and great relationships, two. We are fortunate enough to have developed a partnership with Curia Global. Curia is one of the largest pharmaceutical manufacturers on Earth, and they are currently in charge of all our manufacturing, scale, and distribution. Now, our model is very simple. We are the raw material supplier of graphene. We give this material to forward-thinking companies and let their engineers and their scientists and their innovators move the industry forward step by step, application by application. That's our model. Matthew Chang said it really, really well earlier. He said, the energy transition is coming. He's exactly right. I believe that electric vehicles are important. Because every single one of them on the road represents a step away from a polluted planet and towards a sustainable planet. And if we can actually break this supply chain issue of scale and cost in graphene, we can begin to pull ourselves out of the silicon age and into the age of graphene. And it's coming. So, thank you so much for letting me speak to you today. I'll leave you with one other nugget to ponder on. Today, I really only spoke about its application in one market, and I barely touched the surface of what graphene is able to love. Carbon capture, water filtration, deep space. Those of you who are really excited. Happy to talk with anybody later. But